Hi guys, I think most people today are working on the section about symmetry in our class. And so I just wanted to give a little bit of extra information about what they mean by these odd and even functions. I love this picture, right? It shows us here that if we have an even function, we've got this really lovely symmetry across the y-axis. And if you notice, it's a mirror reflection. Whereas when we have an odd function, we have this lovely symmetry here around the origin, right? We could think of there being kind of a set of axes drawn in here. And it actually takes this, whatever is here, and it rotates it 180 degrees into this position. And it turns out that there's this symmetry that they're going around, it's a rotation around this point, right? That's right at the origin of the object. So even functions always have the y-axis as their symmetry. And let me highlight the y-axis just so we remember that's this vertical axis, right? And that we could take 2 points and they should be mirror reflections of each other across that axis. And that's where they get this, right? That for every point that's over here that's positive x, positive y, that you'll have a reflected point over here. Like say for instance, if I were to go straight up here to the point, it looks like 2, 3, then I could kind of follow this up and find a similar point here, but instead of it being positive 2, it's negative 2, 3. So that's what they're talking about with this rule here, where it becomes negative x, y. As I was saying, odd functions have a symmetry to the origin, which is this point 0, 0, right? That is the origin. And what it actually does is it takes all of the points. So if I say, for instance, I come up here at 2, and I'm at about 3. If this point is 2, 3, then I have a similar point here, but it's negative 2, negative 3, right? It turns both of the points into the negatives, right? So because when we're in quadrant 1, this is plus, plus, and down here in quadrant 3, we have negative, negative. We never talk about symmetry in the x-axis, right? Talking about this horizontal axis. Because it turns out that these are not functions. And you see they've drawn this line here because we call this a vertical line test. If you can draw a vertical line between 2 points on the graph of something, then that is not a function. So we are not ever going to be reflecting across the x-axis. It's always even as across the y-axis, right? The vertical axis. So here we've got this picture again, even. This must be an even function because my symmetry is across the y-axis. Okay, we've got one here. It's x cubed minus 3. Well, we can see that we've got symmetry to the origin, but this is fascinating. We're actually going to get to see now that here with the equation, it turns out the largest exponent in an odd function that shows us this symmetry is odd. That is actually what we're talking about, is what is the largest exponent of this function? And we get this symmetry to the origin if that largest value is odd. Oh, here we don't have any symmetries, right? I cannot draw a line that goes directly through the y-axis. I don't have symmetry, right? There's no mirroring across here. And if it was symmetric as an odd function, it would cross through the origin. So this one is definitely neither. Here, you can have something, though, that is kind of pushed below the axis and still have even symmetry. But here again, we don't go through the origin and we don't have axis, this symmetric to the y-axis, so that one is neither. But here, look, it doesn't always have to be that we have a function that is only up here in quadrant 1 or quadrant 2, But again, we could trace every one of these points, and their exact opposites is this other, right? It's a 180-degree rotation of this part of the curve, so this is an odd function. And I'm going to go ahead and we'll look at just a few of these examples now that talk about this rule, where if we plug in negative x into the function, we should, if it's an even function, procure the original function back out. So let's look at what does that mean. Here we start with this f of x equals 3x squared minus 10. And then they want us to now plug in negative x instead of x, right? We're plugging this value in. But as you guys know, if we square two negative things, right? If we take negative x times negative x, that just gives us a positive x squared. So indeed, we got our same function back, so this is an even function. If you plug in negative x to your function, but you get the opposite function, a negative version of what you had before, then it must be an odd function. So here they've given us f of x equals 4x cubed minus 5x. And when we plug in this negative x for our original x values, which I know it seems a little odd, we're just plugging in the negative. Well, here it turns out that negative x times negative x times negative x, well, we have 3 negatives. And so that does retain its negativity. And when we have negative 5 times negative x, we get positive 5x. So now notice that we were positive, negative, and then went from negative to positive. All of the signs on the terms changed. So indeed, we did end up with negative f of x. So this is an odd function.